In this chapter, we are connecting, or this lesson, connecting intercepts and linear factors. Okay, so let's get into it. Connecting intercepts and linear factors. Okay, I really like the way that your book begins this lesson because it teaches it in a way that's a little bit different than I've seen it before. So connecting factors and x-intercepts. It starts right there. At step A, it says graph y equals x plus 4 and y equals x minus 2. So these functions, laptops can be away, guys. Our laptops. So we have these functions here, y equals x plus 4 and y equals x minus 2. What type of functions are those? Begins with an L. Linear. There you go. So if I graph those, it's going to be a straight line. Right? But don't just take my word for it. Let's take a look at Desmos. Let's see what Desmos has to say. So let's graph them, x plus 4 and x minus 2. There you go. There's my two lines. And if you want, you don't have to, but I think you should. Just go ahead and draw your two lines right here at -4 and at 2. Because that's what's important here. It says, if we look at here, we see the x-intercepts of these lines are -4 and 2. This linear function x plus 4, even though it's plus 4, its intercept is at -4. And x minus 2, the purple one's got an intercept at positive 2. You guys see that? So those are the x-intercepts of those functions. Now, that's cool that we get that. What's another word for x-intercepts? Begins with a Z? Zeros. Zeros. Good. Good. So x-intercept zeros. Okay, cool. That's nice. But here's where it gets interesting. Okay, so we said the x-intercepts are at -4 and 0. Cool. Then it says here, the quadratic function y equals x plus 4 times x minus 2 is the product of two linear factors that have been graphed. Okay, wait. So it's saying that this is a quadratic function. Y equals x plus 4 times x minus 2. They're saying that's a quadratic function. Now, that's not in a form that we've seen it before. That's not standard form and that's not vertex form. So let's just go ahead and confirm that this is actually a quadratic function. If it's a quadratic function, it should have what term in it? An x squared term, right. So let's go ahead, and how should we do this? What do you say, Christiana? Distribute, it's when we have two binomials, it's a special term begins with an F. FOIL, there you go. Nice, so we're going to FOIL, and we get y equals x squared minus 2x plus 4x minus 8. Then we combine like terms, we get y equals x squared plus 2x minus 8. So class, is that a quadratic function? It's not your question. It is. What form is that in? Is that standard or vertex? Standard. It's in standard form. Okay? It's in standard form. All right, cool. So that's a quadratic function, but now here's where it gets interesting. Let's go ahead and plot this function in standard form. X squared plus 2x minus 8. Whoa. Look at the zeros. The zeros of that function and the zeros of its factors are what? They're the same. This is the big idea of the lesson for today. The big idea is the zeros of a quadratic function and the zeros of its linear factors are the same. Does that make sense? Okay. So another way we could have written this is the way it started, which was x plus 4 times x minus 2, and we notice that those are two exactly the same. They're the same. You see? So that's the big idea, is that the zeros of a quadratic function and the zeros of its linear factors are the same. And if you want, you can go ahead and plot the parabola. You don't have to really take a whole lot of time. Just make sure you plot something where the parabola zeros are exactly the same as the linear zeros. The zeros of the linear functions. Cool. And then it says identify the x-intercepts of the parabolas. Well, the x-intercepts are the same, -4 and 0. Step B, it says, what do you notice about the x-intercepts of the parabola? They're the what? When compared to the zeros of the linear functions, they're the same. They're the same. Cool. So that's the big idea of today's lesson. We already hit it. Very good. All right. Now, reflect. Number 1, use a graph to determine whether 2x squared plus 5x minus 12 is the product of linear factors 2x minus 3 and x plus 4. So it wants me to use a graph to determine whether this is a product of this and this. How can I do that? Well, if it is a product of these two linear factors, what do I know about them? They'll have the what? Yes, you're on fire today. They'll have the same zeros. If this is a product of these two linear factors, then their zeros will be the same. So what we can go ahead and do is graph the linear factors. That's what we'll do. 2x minus 3 and x plus 4. And so we see it's got these zeros here. And then we'll graph the quadratic function. 2x squared plus 5x minus 12. And there you go. It has the same zeros, so we know that this is a product of these two linear factors. Okay? Then it says down here in discussion, make a conjecture about the linear factors and x-intercepts of a quadratic function. Okay? What do we know about the x-intercepts of a quadratic function and the x-intercepts of the linear factors? They're the same. Yes. Good. They're the same. You see, we've said that like 5 times today. Because that's the big idea. The big idea is the zeros of a quadratic function and the zeros of its linear factor are the same. Good. Now, we're going to take another step because we'll introduce a form that you don't usually use too much, but it helps us here. It's called factored form. And this is the form that we were in before. So here's our factored form. And in this instance, K is our vertical stretch. And A and B are the zeros. What's another term for the zeros? X-intercepts. Good. So, let's now look at this. So this is our factored form, so let's take a look at it. So use our good friend Desmos here. Now, hold on just 1 second. Okay. So notice when I change A and B, it changes the zeros. You see B is -2, there's my 0 at -2. Make it -5, there's my 0. If I change A, it changes my zeros. If A is equal to 0, there's a 0 at 0. If it's equal to 3, there's a 0 at 3. Does that make sense? You see, so as A changes or B changes, the zeros change. But take a look at that. Look what happens when it's just 1, 0. When it's just 1, 0, it means the vertex is right here on the x-intercept. So that's cool. Now, I told you what it was just recently, but what does k do in this case? The vertical, will it change the zeros if k changes? No, good. It won't. See? Oh, whoops. I gave away the secret. What do you guys think will happen when k becomes negative? It reflects. Very good. There you go. See? Simple as that. Okay, cool. So as k gets bigger, it stretches out, but the zeros don't change. The only way to change the zeros is by changing A or by changing B. You see that? So this is factored form. But the reality is we don't use factored form too much. So most of the time we can just get the zeros from our factored form. And for the record here, let's take a look. 2 times x plus 1 times x minus 4. The zeros are always the opposite of the sign. So the 0 isn't at x, is at positive 1, it's at -1 and positive 4. Okay? Does that make sense? Yeah? Alright, now look. This next part is just writing factored form in standard form. So how do you do it? You just FOIL these and then distribute the number. You see that? They FOIL these and then distributed the 2 in. Does that make sense to you guys? Okay, so writing factored form in standard form, you FOIL and then distribute k in. So go ahead and do that now for step B. Go ahead and do that on your own, please. Thank you. Okay, so we have x minus 5 times x minus 2. We FOIL it. X times x is x squared. X times -2 is -2x. Minus another 5x is -7x. -5 times -2 is +10. Then distribute in that 3, it becomes 3x squared minus 21x plus 30. So in standard form, the function is 3x squared minus 21x plus 30. Any questions? Okay, cool. All right, so 5 and 6 are practice questions. If you want to go ahead and do those. But now if we look on the next page, 275, we have another function in factored form, and it's y equals 2 times x minus 1 times x minus 3. Now the first thing we want to do here before we turn it into standard form is find the x-intercepts, or the zeros, because that's why this form is convenient. This form is convenient because the factors, or the x-intercepts and the zeros, are just staring you right in the face. So the first thing is find the factor of x minus 1. Well, find the x-intercept for x minus 1. Well, that is positive 1 because you flip the sign. And for x minus 3, it's positive 3. But if it's got an x-intercept at 1 and at 3, then that indicates that it has a 0 at 1 and at 3. Does that make sense to you guys? So that's just right there. You don't have to do anything. You just have to look at it and understand how to interpret it. And then they went ahead and did the same thing we did, and they FOILed it out and then distributed it into 2 and got it in standard form. So go ahead for part B. Fill in all these blank spaces here on your own. Okay? Fill in those blank spaces. And it's exactly the same as the one above it, so you can kind of use that as a guide. Yes, sir. All right, I just wanted to get you thinking about it, but let's take a look. Factor x plus 4 indicates an x-intercept of what? Positive 4 and negative 4. Raise your hand if you think it's positive 4. Raise your hand if you think it's negative 4. Nice, negative 4. Okay, and the other factor, x plus 2, indicates an x-intercept of negative 2. An x-intercept of negative 4 indicates that the function has a 0 of negative 4. An x-intercept of negative 2 indicates that the function has a 0 of negative 2. So then we go ahead and fill this in.
Pretty much correlate with the number.
Yeah, it's the same idea. It's just kind of saying the same thing twice. X squared plus 4 times x plus 2 times x is 6x plus 4 times 2 is 8. Distribute in that 2. We get 2x squared plus 12x (2x squared plus 12x plus 16). Okay. Number 7, discussion says, what are the zeros of a function? Well, the zeros of a function are the x-intercepts. How many x-intercepts can quadratic functions have? Yes, ma'am? 2 is the maximum. Are there any other possibilities? Could have 1. Could it have 0? Yes. Let's take a look. 2 is kind of like the ones we've been doing before. Those are 2 x-intercepts. What does it look like if it's got 1? Well, if it's got 1, yes, the vertex will be right there. And if it's got 0, what would that look like? Well, it would look like that. You see? So that's cool. So it could have 0, 1, or 2. So that's a good question. Can never have more than 2. Okay. Now go ahead and do number 9. This one I want you to do on your own. Number 9. So First, you're going to want to get the intercepts, the x-intercepts and the zeros, and then once you've done that, that's when you go ahead and write the standard form.
I'll be quick. Okay. So, first off, where are the zeros? -5 and x equals -1. Alright, so standard form, -2, FOIL it out, x squared plus 5x plus 1x plus 5. -2 times x squared plus 6x plus 5, or -2x squared minus 12x minus 10. Okay? You see? And then I'm not going to go forward and put this in standard form, but the zeros, it's x minus 3, so it's at positive 3. And it's x minus 1, so the 0 is at positive 1. Does that make sense, guys? Okay, cool. Now, next part. Writing quadratic functions. Yeah?
So they, so you have to think that these are backwards.
You kind of gotta flip it. Right? And we're gonna see why a little bit later, why that's the case. Right now we're more concerned about actually being able to graph them. Okay, right now we're thinking about graphing them, less about what the zeros are algebraically. Okay, so writing quadratic functions given x-intercepts. Okay, I'm not going to explain it too much, I'm just going to go right into it. Alright, so you see that here's this example here, but I'm going to do the one that isn't already done for you. So step B, at the top of page 277. Okay. Now, in order to do this, we have to remember our factored form. K times x minus a times x minus b. And then it becomes arbitrarily simple. This is a and b. Okay, so we know a equals -3 and b equals 4. And then it gives all our values of k. So our first value is k is equal to 1. So in this case, we have 1 times x minus -3, so x plus 3 times x minus 4, or just x plus 3 times x minus 4. And then if it wants us to write it in standard form, we have to FOIL it. It becomes x squared plus 3x minus 4x is minus x, plus 3 times -4 is -12. And so that's our answer. This is factored form and this is standard form. Next it asks us to do the same thing for k is -3, so we go ahead and do that. -3 times x plus 3 times x minus 4. Well, that's already factored form. And then we've already factored that out, so we don't have to do it again. It's just negative 3 times x squared minus x minus 12, because it's the same exact thing. Okay? And then we distribute it. Negative 3x squared, negative 3 times negative x is positive 3x. Negative 3 times negative 12 is positive 36. Does that make sense? Okay, so like I said, it's like, once you kind of get what you're doing here, it's actually pretty simple. K is 2, just 2 times the same thing, x plus 3 times x minus 4. And remember, we got this because it's x minus a times x minus b. A is negative 3, so x minus negative 3 is x plus 3. And b is 4, so x minus b is x minus 4. And it's the same thing once we FOIL it, so it's x squared minus x minus 12. And then distribute that 2, and it's 2x squared minus 2x minus 24. Okay, and that's it. Does that make sense to you guys? Any questions about that? No? Look, these 2 chapters are a lot of information, and it can seem like it's like there's so many lessons, we've learned so many different things, but the reality is, like, you just learned standard form, vertex form, and now factored form. If you understand how to use those 3 forms, then you understand basically everything from all of these lessons. Okay, you got to be able to graph them. You got to be able to understand what they're telling you, right? The vertex is in vertex form, it's telling you what the vertex is. In factored form, it's telling you what the factors are. In standard form, it's just standard form. Okay. All right. So, any questions? Okay. Now, praise God. Homework. Oh. Well, I was gonna give you only like 6 questions, but if you really want more that much, I can give you more. 1, 2, we good? We good? Okay. 1, 2, 5, 6, 11. Please don't throw things in my room. Thank you. 1, 2, 5, 6, 11, and 12. That's it. Okay. I'll write it down. It's page. It's not up there yet, but it will be today. Page 279.
So it's 1, 2.
I'm writing it down. Numbers 1, 2, 5, 6, 11, and 12. That's it. Any questions? All right, you guys have plenty of time. You have like almost 15 minutes. You could probably get that done, so go ahead.